Okay, the topic for the day today is hyperbolas. And if you recall, the way we get a hyperbola from a conic section is to have two cones, points together, and take a slice perpendicular to the table that this all sits on, and it gives you a graph like this. It has two parts to it. This is a hyperbola. All right, and what we're going to do today is talk about the features of a hyperbola and the equation for a hyperbola, and it all works very similarly to that of ellipses. There are foci, except the shape is different and some of the measurements are a little bit different. So let's go ahead here. If we take a look at the graph that we have in the box, right here and right here, those are the foci, all right? So let's put a little arrow here. This is a focus. Put a little arrow to this guy here. This is a focus. So, an interesting thing, if we go a little bit further on down the page here to our next drawing, we're going to start talking about some of the features of the graph. So, a hyperbola consists of two smooth branches. Those are these. The turning point of each branch is a vertex of the hyperbola. So let's get out another color, and we're going to do that right here and put a little arrow. That right there is a vertex. And this right here is a vertex. Now, today, we're only talking about hyperbolas that actually have a center right on the origin of 0, 0. If we had one more day that I could spend on new material, we would talk about translations of these to places where the center is something other than the point 0, 0, but we ran out of days. Here's to the 9 snow days we had.
Darn.
All right. The segment connecting the two vertices is the transverse axis. So I'm going to take this little pink pen and I'm going to draw this right here, and I'm going to put an arrow here. This is the transverse axis.
Didn't you learn about those in geometry, like a transversal?
Okay, I'm not sure what all you learned about in geometry, because off the top of my head, I'm not that familiar with the exact curriculum that you have heard, but a transversal crossing two parallel lines is something a little bit different. Okay. So, this lies on an axis of symmetry here, and note something. The length of this thing from the center out to the vertex is the distance A, and from the center out to this vertex is the distance A. So the length of this transverse axis is actually 2A. So length equals 2A. Okay, back to our paragraph. The two foci also lie on the axis of symmetry. The center of the hyperbola is the midpoint between the two vertices, which also is a midpoint between the two foci. So just as for an ellipse, the foci are plus or minus C, 0. The distance between the two foci is 2C, and the vertices are plus or minus A, 0. And the distance between the vertices is 2A, okay? Since the vertex P, and right there you can see that P, is on the hyperbola, it must satisfy the equation P, F1, and here's F1 over here, minus P, F2 equals k, but you can also see that. I'm not worried about that. We don't really need that today. Not for the simple things that we're going to do today. Okay? So in our very simple world, this box is very, very important. This is a horizontal hyperbola. This is just like the picture we just saw. This is a vertical hyperbola. Here are their equations. Notice they're minuses. We haven't had an equation that's a minus yet. The vertices, notice how they're different. The foci, notice how they're different. There is an equation that can help you find your A, your B, and your C. And the B is something that's actually quite interesting because this has something that the other shapes didn't. These have asymptotes. Now, this is interesting. To this day, still some of you are saying asymptotes. It's not like chemistry. It's not an isotope asymptote. It's an asymptote, like a tote bag. Tote. Asymptote. Okay? I want you to see on here, the asymptotes are lines, and they're right here. They're kind of like diagonal lines. These are the asymptotes, and here are their equations. All right? Here are their equations. Now, it's very interesting. This B, this right here is the distance B. This right here is the distance B. This is an equation that pertains just to hyperbolas. All right? And here's the equations for the asymptote. So let's go ahead, and we're going to use the information in the boxes, which you should keep absolutely handy while you are doing these problems. A hyperbola centered at 0, 0 has vertices plus or minus 4, 0, and one focus at 5, 0. What is the standard form equation of the hyperbola? All right? So keep in mind, the vertices are plus or minus A, 0, right? And the foci are plus or minus C, 0. And we're getting that right from our box up here. So when we know that, we can say that A is going to equal 4, and B, C is going to equal 5. Would you agree? So far, so good. And if we want to go to our graph, let's see, I don't know if I want to move this up. We'll graph in a minute. All right? Here's our equation. C squared equals A squared plus B squared. So I've got 5 squared equals 4 squared plus B squared, because I need B. So I've got 25 equals 16 plus B squared. And that gives me 9 equals B squared. So B must equal 3, right? Plus or minus. Does that make sense so far? We needed that. Now, would you agree that because our vertices are in this format and not this format, and because our focus is in this format and not this format, that we have a horizontal hyperbola? Okay? So this is our equation. So our equation is going to be, now I'm going to have to move this up. X squared over A squared minus Y squared over B squared equals 1. So this is going to be X squared. What's A squared? 16 minus Y squared. What's B squared?
25. Wait, no, 9.
9 equals 1. All right, and there's our equation. Now, let's go ahead and do this. This right here is a vertex, and this is a vertex. This is a focus, and this is a focus. All right, now a really cool thing that we can do is actually find our asymptotes, and our asymptotes are y equals plus or minus b, which is 3, over a, which is 4x. So 3/4 x and negative 3/4 x. So if I'm here at the center, 3/4 x, let's give me a new color here, which is up 3 and over 4, right? This is going to give me an asymptote right here. Negative 3/4 x means down 3 and 4 to the right. And let's draw that in. And the reason why we draw these in, which is just really handy, is because it's an asymptote, and your hyperbola is going to approach this. So now you know, here's a vertex, so it's going to come from this, and it's going to go like this, and it's going to go like this, and over here, like this, and over here, like this. And there we have drawn a hyperbola. Pretty cool. Let's flip to the next page. It says, what are the vertices, foci, and asymptotes of the hyperbola with this equation? Now, this is pretty cool. So, would you agree that our standard equation, when we're looking at hyperbolas, equals 1, doesn't it? Ours equals 63. How do you get it to equal 1? Any guesses? How about divide everything by 63? 63, 63, 63. So this will give us y squared over 7 minus x squared over 9 equals 1, right? Would you agree that's pretty accurate? Okay, let's go back to this box for a second. I have y squared minus x squared. That's this one. This one is x squared minus y squared, right? We have a vertical hyperbola this time. So with a vertical hyperbola, our a squared comes under the y squared, and our b squared comes under the x squared. So we got to find a and b, all right? Let's put a little arrow right here. This is a squared. This is b squared. So that means a equals the square root of 7, and b equals 3. Agree? So far, so good? And remember our equation that said, whoops, not c, it's c squared equals a squared plus b squared, right? Because we need c. So we have c squared equals a squared, which is 7, plus b squared, which is 9. So we have c squared equals 16, which means c equals plus or minus 4. Agree? Okay. Let's start stating what this is. So our vertices are a. So this is 0 plus or minus the square root of 7. Vertices off the list. Foci. That's C. This is going to be 0 plus or minus 4. That's off the list. Oh, we need some asymptotes? Let's go back to our little box here. Plus or minus A over B x. All right, that's our formula for our asymptotes, those diagonal lines. Who knew a asymptote could be a diagonal line? So we have y equals plus or minus the square root of 7 over 3x. And then we want to graph the equation, which is really nice because I don't have any graph paper here, so we'll just draw it. It's okay. Guess I could have put graph paper on the page. Okay, so first of all, my vertices is plus or minus the square root of 7. It would be really handy to know what decimal the square root of 7 is. 2.6-ish. All right? There we go. Vertice. My foci is at 4. So there that is. And down there at -4. Square root of 7 over 3. So, whoops, clear that. Square root of 7 divided by 3 gives us 0.88. Really, really close to 1. So, almost going to be a 1, but not quite. And not quite -1. So not quite as steep as 1 would be. 1 would be a perfect diagonal line. This is a little shallower than that. So now there we go.